many field trips. People are still trying to really find an analog, perfect analog for what we see. Oh, there is nothing here. Why is that? Huh? But I was just talking, for each PowerPoint presentation you need to do that. No, I didn't need to do that.
This PowerPoint is not on display right now. Even
Oh, I thought you are saying do what you did.
that also can be done, but otherwise you have to put it.
Oh, yeah. Okay, sorry about that. You guys didn't discover it before? You thought I was talking to myself. Nice job. Okay. See, that's the reason I hate to stand here. I like to move, and he doesn't want me to move too much. And
So what did you show us any more before slides before this?
yeah. And you are very quiet. Okay. ठीक है. We'll lead. I mean, we have less time.
So we were looking at that, trying to understand.
Okay, I'll show you what we did. So we have all this on this reservoir. We have a lot of data on this reservoir. We have different analysis in the core laboratories. We have all different possible open hole logs, and then we are able to build very systematic packages, facies distribution and vertical sections in the core. So I am always going to focus on this approximately 100 centimeters of core. It is a full diameter core, and we have been able to identify many lithofacies in that. These are typical of lacustrine carbonates and this shrub facies. Tuft is a overlapping sort of parts or balls, broken. It has that appearance, tuft. But it is not a shrub. It is a framestone, but it can be either composed of tufts or some people pronounce it as tuft. It is like tufa, tufts. It is nodular. It is large nodules, sort of nodules. We have spherule rich packstones, grainstones, but the main facies here, which is prolific, is a framestone. Framestone is one of the best carbonate facies to be a reservoir. These are in India, carbonate geology and carbonate petrophysics are slightly behind. I don't know how things have changed, but at least when I worked in India, the carbonates were really not very popular in universities in terms of petroleum geological work, but hopefully that situation has changed. Because I do not see internationally people coming from India to deliver carbonate petrology or carbonate petrophysics or carbonate geology presentations at major scientific venues. Maybe the problem is also data release from the oil companies. If they are not interested, then you are not going to get it. Lithofacies variation within 5 centimeters, I will show you first. We are going systematically in. So what I am displaying here is 5 centimeters. And remember, I am only telling you the story. I am part of the 4 people team that has done this. Okay, like I said, we always have a geologist, petrophysicist, geophysicist, reservoir engineer, minimum 4. And I got to work with some of the world's topmost subject matter experts, so learned a lot. This is a real core, and these are the real structures, and then this is how we make the diagrams. There are software also available for this. What are the compartments I see within a 6 or 7 feet? Compartments is a reservoir engineering term. Those are the compartments with identical petrophysical rock types, not geology, but petrophysical. So, based on that, we identified and correlating with the lithostratigraphy, you can see within 2.5 meters there is a lot of variation. Now, core description, when it is put next to this, is an oil based mud image, this is not a water based, it is a deep water well, so very risky to go in with water based. We can see some of the structures, and what are those structures in full diameter core? Look at that. That is what we call shrub. It is evident it is a shrub. This is inorganic lake. So, there is organic matter, but no fossils. Lacustrine growth is by precipitation right there in situ, and because of various dynamic, don't think this is a small lake, we are talking about rift basin, a rift basin between Africa and Brazil. There is a rift basin between Africa and the eastern side. So, this goes back to Gondwana breakup, from that time how the breakup started. And
What shrub is taking some different understanding. I thought that it has something related to the plant fossil which probably are recorded over there.
it looks like that, so the name shrub.
It is just the resemblance of the shape we are talking about.
It is in response to specific physiochemical environment, the calcium carbonate grew, that texture happened with such growth. Many of them are broken, they all were shrubs, just like stromatolites. Sometimes they are preserved in a narial shape. Okay.
The form is typical of lacustrine stromatolites.
Yes,
In section photograph.
yes, absolutely.
Because the word lacustrine was slightly confused.
Lake, but depends on how big lake is and what is supplying to the lake, adjoiningly what are happening, what are the tectonic movements, how deep it is. It has beautiful, incredible facies. You wanted to see something like a narial, right there it is. It is a head of the shrub. There are some conventional structures and textures, but that is bound to happen, it is a normal basin. Now, I am showing you some whole core slabbed and compare it with the borehole image, as well as with micro CT, as well as with normal CT. So, what you see here, this round feature, remember this is oil based image. I said there are many advancements in oil based imagers. That is same as this. We have a fairly good depth correlation. We put everything next to each other, correct the depths. The logger's depth is always taken as the depth. We adjust all others depth, including driller's tally, core laboratory tally, everything gets, the accepted norm is the logger's depth. And then there are such beautiful structures, brachiated and wavy fabric. They are very silica rich sometimes, and these are full diameter cores, extremely expensive. 1 year program to plan, design, acquire, and do the first testing. This is the helical CT. Nowadays, I really love this. There is a helical. So, we are hand holding the sample literally and analyzing it with CT. Now, I want you to think that thin section importance cannot be overestimated. I had an intern working for me from university. He had just joined, and his beautiful work, then he showed it to me, and then we put labels on it. So, within one single zone of what? Less than a meter, you see all these facies. All are porous permeable. But from production point of view, from helping the reservoir characterization and modeling point of view, keep thinking what would you like out of it? How would you describe this that helps? Because same facies, same exact facies, sometimes are porous, sometimes they are not. What can capture it? And when you have a number, you have a number. What you don't know is how that number is hidden in all this. Because these pathways through which the oil has to migrate and we have to produce from deep depths is not like a water tanky on the terrace and there is a pipe coming straight into my house. The material is so heterogeneous. Okay, I know we are a little late. When it is good, it is very good. Look at the porosity, 10%. Look at the permeability. Why? Evidence is on the left. All blue epoxy. Dendritic growth of those shrubs. So, it is like having conglomerate which is not cemented. It gives, this ACM gives you a sense of the scale, mega, micro, meso, macro. You can see all the features, and then you can see how even in an ACM there is variation in the open space. So, at all scales of observation, the features change. And diagenesis, mind you, in carbonates can go either way. It can create porosity, it obliterates porosity. Diagenesis is not only creation of porosity. More often than not in carbonates, it is a destruction of porosity. Permeability changes in that same chord interval, the 100 centimeter. You can see how many orders of magnitude it is changing. Observe, important thing to take home is that it is changing so much within 100 centimeters. How is it linked to the water saturation? Look at it for yourself. Within those 100 centimeters, the good news is distinctly there are two zones. But where are they with respect to depth? This is not a depth we are plotting. You see what I am saying? There is a lot of samples at almost 100% water saturation. There are a lot of samples at about 20%, and they range in permeability quite a bit, from less than 1 millidarcy to 200, 300 millidarcies. But when you go back to this, they are not in layers, it is not a layered rock, heterogeneous. And then comes one of the most difficult chapters, asphaltenes. Asphaltenes have entered in addition to oil, or even before the oil, or now they have become asphaltenes. So, asphaltenes is like very hard, is not exactly tar, yeah, pardon? Oh, it will block the pores. And many times that asphaltene, we have to first determine was it asphaltene in subsurface, because asphaltenes precipitate when things come up the hole in response to the pressure. This we determined it is in situ. So, this is going to be what? In many cases it is going to be oil wet reservoir. Wettability is a mixed wettability, not everything is water wet. Very nice looking picture and hope, big pores. Guess what? Can you read the permeability number? 0.0068 millidarcy. My skin has more permeability. Why? Because this is localized. These pores, they are not connected, they are not talking to each other, at least in this two-dimensional picture. When we look at the conventional relationship of porosity and permeability, this diagram includes like 2 or 3 orders of magnitude. So, I am now going to jump to NMR T2 distribution. In this I showed before, it was from this. All we see are 2 populations, bound, free, but distribution very different. T2 cutoff shows clearly the reason how the permeability is varying where. And then when we put everything together with logs and develop correlations, we realize the main culprit is the scale of measurement and that there is no match. And then we figured out what are the real scales for each measurement. And then we found that there is so much distance, there is no matching. Critical measurements are not matching each other in their sample, what is the sample size required in core laboratory. And then we compared that to the log resolutions, and you can see on one hand NMR can have a 6-inch resolution, but you have conventional logs except for density, all conventional logs are like 2.5 feet. Seismic cannot really come to that level. But what is good news is all logs can be available at 1 foot. Even if a log has 6-inch resolution, 1 foot it is good only. But all these logs can be available at 1 foot. So, we have proposed that keeping this in view, we need to instigate the industry. This is one case, but we need to find many more and they will come out looking at this paper, because only for one field service companies are not going to react. It has to be commercially viable proposition. So, my friends, this brings me to the conclusion of course, and now you are going to be ready. Even if you are not ready, you are going to take the test. Take it quickly. Don't think too much. If you think too much, over information can lead to misleading conclusions. They are objective questions, they are common sense questions. If you have been listening 50% of times, you will get 50%. If you have been listening 80%, you will get 80%. If you have listened 50%, but you are 100% smart, you will get 75%.